All right, hello everybody. Today we're going to be doing 8.7 notes, which uses base E and natural logarithms. Before you get started on these, you want to really make sure that you understand the previous notes because it is really important that you understand logarithms up to this point. Otherwise, this section is going to feel like an entire chapter because everything that we've learned with logarithms we're going to be going over today, but this time just with base E and natural logarithms. So, if you've kind of been lost, you might want to go back and try to get clarification on some things. Otherwise, if you have questions, just let me know kind of as we go through this week. Our goal today is to evaluate expressions and solve equations involving natural log and E. So, we'll talk about what the ln and E means. ln is natural log, and then E is it's a variable. It's the natural base, and it's a value of 2.71828. And you can see that there is an ln button on your calculator if you're using a scientific calculator, and there should be an E button too. And sometimes it looks like no, what is it? I'm sorry. It's going to be written like this, E to the power of, like that. Or it might have an X here, but it uses a base of E. So that's what the button on the calculator will look like, just kind of depending on which calculator you have. But we use this when we're talking about, let's go about natural logarithm too. So the natural logarithm is just with the natural base of E. So it would be log base E of X. This would be the exact same thing as if I wrote natural log of X. So it's similar to how we write the common log. The common log, we don't ever have to write the base 10. Here, instead of writing log base E, we just write natural log because it has the natural base to it. People sometimes ask, why is it ln instead of nl? My best guess is that it was developed in a different language, and a lot of you guys that are in foreign languages know that the descriptive word comes after the word. So instead of saying the blue crayon, we say crayon of blue in other languages. So I'm guessing it said log of natural. That's my best guess. So it is ln instead of nl, but don't let that confuse you. So log base E or ln, these are the exact same thing. For a while, you'll probably write ln as log base E because it might help you out a little bit. All right, let's talk about why we need these things. So we need these because for continuously compounded, we talked about interest before, and compounded monthly or semi-annually or quarterly. And so, like, there are things in life that it doesn't say, oh, so bacteria grows, it's going to sit there until the end of the month, and then bam, it's going to add some bacteria. So instead, it continues to grow continuously instead of at the end of every month or twice a year or 4 times a year. If it's bacteria, it just is natural for it to continue to grow. So that's when we're going to use these formulas. So the formula can be written as, some people call it the PERT formula, P times E to the power of R times T, or it can also be A equals P E to the power of K T, okay? Science classes will often use instead of R as K, but just know that K and R are used interchangeably. It's just the rate. Okay, so that's the big thing here, is that the rate can be written as K or R. So just get used to that's interchangeable. All right, so let's see, what else do we have? So we are going to be asked to convert, which you're like, okay, yeah, Miss Massoyan, or sorry, Mrs. Fox, you're talking about converting every single time. But in this case, things are a little bit different because it won't look like something that you've seen before. So you might see something like this, or this. And these might look a little bit different right now, but it is actually no different than what you have been doing in the past. So when we convert this to a logarithm, log, the base was e, so this is log base e of 6 is equal to the exponent, which was x. However, we're not going to leave it like this because up here we said if we had log base e, we could just change it to ln. Well, here we have log base e. So that means what we need to do is change that to ln. Okay, so the natural log of 6 is equal to x, and that's how it's going to look when we convert it completely. All right. So like I said, you're just gonna have to get used to that two-step. Eventually, I'm sure you're gonna go from here to here, no problem, and you're not even gonna have to write that in between step. Okay, but for right now, if that in between step helps you out, awesome. This next one, what I tend to do is again, instead of writing the natural log, I am going to go ahead and I'm going to write it as log base e of x is equal to 2.7. That way, I can see what it is I'm working with here. Then when I go to convert it, my base is e to the power of 2.7 is equal to x. And then I converted it. Okay. So now let's actually talk about how we're going to solve this. So we learned how to convert it. Now let's learn how to solve it. This first one, since we already know how to convert it, let's just write that converted answer in. If we convert it, we know we get the natural log of 6 equals x. And the cool thing is x is already by itself. Well, your calculator has a natural log button on it. So type in the natural log of 6. And it's going to tell you that x, and it's going to be an approximate answer, is something. And that something is 1.7918. Okay. So that would be your answer. Now, there's another way you can go about this. I'm going to show you the other option also. The other option is, and we did this in the last section, I believe it was 8.6, is you can take a logarithm of both sides. Like this. Okay. Now, let's say you didn't do the natural log. Let's say you did maybe base 10. So the common log. It's like that. Now, that's awesome. You could do that. What your goal here is that you're trying to get that x to come out of this logarithm. Awesome. That'll work. However, then you're going to have to divide and blah, blah, blah in order to get x by itself. However, if you used the natural log on both sides, I'm going to show you what happens. And there is a purpose of why you want to choose a natural log when you're dealing with e here. So with the natural log on both sides, what you actually have here, I'm just going to write this in and then I'm going to erase it, is you have log base e of e to the power of x. I'm going to leave this one on its own. Actually, I'll keep that. Okay, so now you might remember, oh wait, here's our properties over here. Let's actually write these properties in so we know what we're doing to use them. Okay. So the natural log, if you have the multiplying x times y, you'll remember that this is natural log of x plus the natural log of y. These are all your log properties. They're the exact same whether you're doing the natural log, log base 10, log base 15, log base 5. It does not matter. So the fact that you're doing log base e now with the natural log, these properties are all still the same. So with the quotient one, you're going to have subtraction. okay? What's in the denominator is what you subtract. The natural log of e, okay? What you actually have here is log base e of e, right? Natural log is log base e of e. You guys already know that that's 1. Whenever you have the same base as the of part, that's 1. So that answer there is 1. Okay. If you have the natural log of e to the power of x, that answer is going to be x. Because remember that x comes out front times the natural log of e, that's just 1. So you're going to have x there. Okay, that's how we can look at it. So over here, when you look at this over here, the natural log of e to the power of x, you guys already figured that out. That should just be x. Here's why, though, because we're taking log base e of e to the power of x. You're using this idea. The x comes out front. You're multiplying by 1. So what you actually have here is x equals the natural log of 6. Okay. Typing that into your calculator, you're going to get x as approximately 1.7918. Decimal didn't show up. Okay. So regardless of if you take a natural log of both sides or you convert, you are going to get the same answer. It does not matter which method you take. Okay. So sorry, my water bottle whistles there. The next one, the natural log of x is equal to 2.7. All right, so on this one, let's try to convert it. Okay, so remember what you're dealing with here is log base e of x is equal to 2.7. Okay, so we have e to the power of 2.7 is equal to x. Okay, cool. When you converted it, you got x alone. And now that x is alone, there's that e to the power button on your calculator. So you can evaluate and get that x is approximately 14.8797. And you're done. All right, so this next one. Lots of different options here. All right. No matter which method you take, you're going to get the same answer. So I'm going to show you a couple different methods here. The first method is you could try to find a base that you could turn 26 and 2 into. Unfortunately, that's not going to work because there's not a common base. So you could take a logarithm of both sides. Okay. So maybe you have log of 26 to the power of x is equal to log of 2. All right. That x will jump out front. X times log of 26 is equal to log of 2. Now, you could use any base you wanted to as long as you kept the same on the left and on the right side. Okay. And what you would get is you'd have to then divide both sides by log of 26. So you would end up with x equals log of 2 over log of 26, and then you would evaluate that in your calculator. Okay. If you wanted to, and I'm just going to write this right over on top, if you would have taken the natural log, it would have done the exact same thing. So you would have had ln, here you'd have ln, here you'd have ln, here you'd have the natural log, and here you'd have the natural log. So you get the exact same thing. It doesn't matter what log you take on both sides as long as it is the same. Okay, so you're taking a log of 2 over a log of 26, and as long as those logs are the same, you're going to get the exact same thing. All right, so let me erase this jumbled mess. I'm going to write what I got down there at the bottom, but so one option that we had was log of 2 over log of 26. You could have also gotten the natural log of 2 over the natural log of 26. The other way that you can do this problem is you can just convert, okay? Let's say I were to take this and convert it to a logarithm. I would have log base 26 of 2 equals x. And with that, I'm already done because x is alone. But the problem is in your calculator, you can't quite type this in. So what you're going to need is to do your change of base formula. So we'll make a little note that this is the change of base formula. And what you're going to get when you do the change of base is you would have any logarithm you want on top and bottom. Remember, the 2 goes on top and the 20, oops. I don't know if it's going to let me write it. I'm so close there to the edge. Log of 26 is going to be on the bottom. And you'll notice that it doesn't matter which base you choose, but you have to, in order to put it into your calculator, you need a common base or a natural log to put it in your calculator. So that x that you're going to be choosing, you definitely want it to either be 10 or e, okay, so that you can put it in your calculator. But it doesn't matter, because no matter which way you go about solving it, you're going to get the same answer. And when you go to type that into your calculator, the answer that you will eventually get is that x is approximately 0.2127 is what you should get when you type any of these into your calculator. All right. And you can check that, because if you, 2 and 3 are both very easy to check. The natural log of this, make sure it equals something close to 2.7. 26 to this power should get you something close to 2. And again, I say close to because these are approximates, so they're not exact answers. This one was another easy one to check. So a lot of these you can actually check now that we figured out what we're doing. All right, let's go on to the next page where we're going to do some more solving. One more thing before we move on there. I brought up this compounded continuously. This is what we're going to get into in 8.8. This was kind of just my explanation is what is this E number and why is it there? But we'll get into more details about that once we start on 8.8. All right, so let's see. Number 4, in order to get e to the power of negative x, we're solving for x here. Some people get a little bit confused when they're doing this because that e, they think of that as a variable. That's not a variable because you know what the value of e is, that 2 point blah, 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 blah number, 2.71828, right? So in order to solve for this, though, we have to get this portion of the equation by itself. So pretend that you had something like 4x plus 8 equals 17, and you had to get x by itself. You'd start by subtracting the 8 and then dividing by the 4. So we're going to do that the exact same here. So subtract the 8. We're going to get 4e to the power of negative x is equal to 9. The next thing that we're going to do, divide by 4. Leave that 9/4. We already have approximate answers that we've been dealing with, so if you can leave it exact for as long as you can, that's going to help us out. All right, so now how do you get it out of an exponent? So this is where you have some choices. Just like in example number 3, you could choose to take a log of both sides, or I like to always convert. I'm a huge fan of just converting it. So if you convert, we're going to get the log, the base is going to be e of 9/4 is equal to negative x. Okay. At this point, ln is just, log base e is just ln, okay? That is just the natural log of 9/4. So in order to get x by itself, the only thing you can do otherwise is multiply both sides by -1, and we would get x equals negative the natural log of 9/4. Okay. And when you type that into your calculator, you're going to get x as approximately negative 0.8109. Now, you could have typed in natural log of 9/4, hit enter, and then divided by -1 or multiplied by -1. It's not going to matter. You're still going to get that same answer in the long run. All right. Usually, I'm used to answering a lot of questions during this unit or during this section, so I apologize that I'm not able to answer all your questions right now, but make sure you take notes and figure out what questions you have and let me know. All right, so in this next one, the part with x in it is this the natural log part, so that's the part we're going to get by itself. So again, think about if you had 5x plus 2 equals 10, how would we get x by itself? You'd start by subtracting 2 and then dividing by 5. So that's how we're going to start this. Subtract the 2, divide by the 5. All right, divide by 5, divide by 5. Now we have the ln of 6x is equal to, we're going to leave it 8/5. Again, don't write that as a decimal yet because we're not done yet. All right, so the easiest way I would say to go about this one is, again, just convert. All right, so think about this as log base e of 6x. That'll be a little bit easier to convert if you're thinking about it that way. Okay, so what we have when we convert is e to the power of 8/5 is equal to 6x. And now you're almost done. Like, don't even think about this side. Look at here. How do you get x by itself? You guys know you're going to divide by 6 on both sides. And there you have your x. X is alone. So you have x is equal to e to the power of 8/5, and then you're going to take that answer and divide by 6. Make sure that when you're typing this into your calculator, you're going to have it like this. Make sure 8/5 is in parentheses before you then divide by 6. Okay. So when you type that in, you should get approximately 0.8255. Okay. And that should be your final answer. Now, I don't usually ask for like exact answers in this unit, but if I did, that would technically be your exact answer. But we usually will just get our decimal answers, and we usually round to 4 decimal places during this unit. All right, so the next set of examples are just writing expressions as one logarithm, and this helps like what we did in a couple of sections ago when you had logarithms on both sides and you had to use that property of equality to write them as a single log and then set the of part of the logarithm equal to each other. So in this one, it just says, please write it as a single logarithm. So you're just going to do your best to write it as one term instead of many. Before you can do anything with that subtraction sign, you're going to have to take the 6 and the 2 from out front and make those as exponents. So you kind of work backwards as to how we usually work. So we have 8 to the power of 6 minus the natural log of 4 squared. All right, so then with that subtraction problem, that is actually the quotient property. So you have the natural log of 8 to the power of 6 over 4 squared. Okay. Now, if I wasn't asking for anything else, you technically could have been done there, but I would try to simplify this nastiness a little bit more. And so what I want you to look at is 8 and 4 actually can be written with the same base. So what would be a common base for 8 and 4? It would be 2. So 8 is written as 2 to the 3rd power. 4 is written as 2 squared. So what we actually have here is the natural log of 2 to the 18th power over 2 to the 4th power, which then simplifies, now that they have the same base, this is just the natural log of 2 to the 14th power, which is the same thing as 14 times the natural log of 2. So either of these answers I would take, okay? And if these can be written as the same base, you always want to look at that. Can you write them as the same base? They're not always going to have a common base, so just be careful there. All right, so the next one. The next one, again, you're going to take anything that's out front, and we need to make those into exponents. Okay. Let me actually erase that so we can read it. All right, so we're going to have the natural log of 5 squared plus the natural log of 2 to the 4th plus the natural log of 5y. These should actually have parentheses there. I don't know why I missed those. Minus the natural log of 10 to the 3rd power. All right, so then anything that is being subtracted actually follows the quotient property. So when we go to write this as a single logarithm or as the natural log, this right here, since it's being subtracted, that goes in the denominator. Everything else that's being added goes in the numerator. If it's being subtracted, denominator. All right, so we have the natural log. In the top, we're going to have 5 squared times 2 to the 4th times 5y, and in the denominator, we have 10 to the 3rd. Now all we have to do is simplify this nastiness. So I'm actually, 5 squared is 25, 2 to the 4th is 16. So 16 times 5 times 25. We actually have 2,000 on the top. And we have 1,000 on the bottom. And then we have that y also on top. And that just simplifies to the natural log of 2y. And done. So all you really have to do here is you didn't have to find a common base because 5 and 2 don't have a common base. 5 and 10 don't have a common, they just don't all have common bases. So what I'm going to do here is I'm just going to multiply the top, figure out what that is, multiply the bottom, or 10 to the 3rd, figure out what that is, and then 2,000 times 1,000 is just 2. So I just simplified it, and I'm done. And so that's all I have for you guys today, and if you guys have questions, let me know.